Today I want to talk about how to play GLSL on Ruby and with the OpenFrameworks. And I will introduce the GLSL and the OpenFrameworks. Okay, first, I'm Autoki. Yeah, in Chinese, my name is 苍时弦也. I'm a web developer and a game developer. I majored in digital media design. So I did not do design, but I love programming because it is a creative works. So I use my programming skill and my digital media skill. And I joined the 5 times Ruby about 1 month ago. Yes, I Photoshop it, lighting, powerful. Yeah, my company is very friendly, so I love it. And it is start from Taiwan's Ruby community. So I have many chance to join the community active. Yeah, this is my company. And so you can see that magic. And one more thing, the Ruby Conference Taiwan will be held in December 2nd and 3rd. So we are call for paper, and I hope everyone join us and have fun with it. Okay, today I will show how I play the GLSL with Ruby and the OpenFrameworks. But many people did not know what is the OpenFrameworks or the GLSL. So I will show some demo first. And I will introduce the OpenFrameworks and the GLSL. And the most important part is how I create a shader generator. And it will write in the Ruby. So I can write some Ruby code, but it will convert to the C language, C-like language. And this code could control the GPU and draw something on the screen. But if I want to use it, so I have to using the Ruby in C++. So I will talk about how to embed the Ruby in the C++. So the shader usually used for the 3D models. So we have to know something physical knowledge. Okay, my demo, I will create a diffuse shader. What is a diffuse shader? In physical, we define the light will reflect it. But in the real world, the surface is not smooth. So the diffuse is used to calculate many light applied on one point, and how the point light will be applied. So it is a demo time. Okay. Now you can see this is a 3D ball, and I write a shader to show this ball. The shader can accept some data from C++ language. So I move my mouse, the light source will be changed. And I also can load some model. Okay, for example, I loaded the RubyKaigi 3D world. So I rotate it. You can see the light source will be changed. And you may think is it a video? No. So I change it to Ruby Conference Taiwan. It also works. Okay. And I can change it to 5 times Ruby.Taiwan. The shader usually can draw a model. So one shader can apply to many models. If you want to more effect, we may write a new shader for specified model. For example, this is a 3D character. This is a Unity jump, and I added more detail on the diffuse shader, so it will display more detail. And it is also possible to change some color from light. For example, I change the color to the green or blue. Yeah, and I think everyone have some detail about what is the shader and the GLSL. If my talk still have time, I will demo how to write a Ruby code and adjust this demo. Okay, so before my talk start, I will introduce who use the OpenFrameworks and what's the shader mean, and what is the GLSL. You can see this video because OpenFrameworks usually used by artists. They did not know how to program it, but they have to create some digital artists. So they use OpenFrameworks because they wrap the OpenGL, OpenCL, and they can use this to create some visual or audio effects. So these artists may not know how to program it, but it could create some very special effect. Okay, so the shader, it is a screenshot from 3.js. Okay, and I adjust the value. So you can see this screenshot, the model's surface is very smooth. But when I change it, the surface is not smooth. Because shader can accept some data from C++ program, and this can create a real-time rendering effect. So our 3D model will be dynamic. So if you try to write a 3D game, you have to use it, and your game will have many different effects, but you only write one or three shader, and they can do many things. So what is the shader? The shader usually have two types. The first type is Vertex Shader. The Vertex Shader is mean a point on the 3D space. So Vertex Shader usually use to calculate how to move a point in a 3D space. And it will have many steps. So the 3D model will move to the point, and this point is about in a 3D world. And the camera also will move this model to let this model can be camera capture it. But our screen is 2D space. So from 3D space converted to 2D space, the vertex shader, you also do something and transform it. So you can see the final result on vertex shader return. We use the 2D space to view it, but in the 3D space, the model will be transformed. And the fragmented shader is about how to draw the color. So if I do nothing, just return a color for it. Now I just see I just see nothing, and it's on no 3D effect. But if I added some diffuse effect for it, now it have a shadow, so I can see a 3D ball. This is a shader, so we can use it to create a 3D effect. And what is the GLSL? Because we have to control the GPU to draw something, but we don't know the detail about GPU. So OpenGL provides us a language, and we can use a C-like syntax to control the GPU. So if you use the GLSL, you just a cat also can control the GPU. Yeah, this case is our company's case. Yeah. So the most important part is about how I write a shader generator and convert the Ruby code into shader code. So first, I will talk about open class to extend the C++ class, because I have to communicate with the OpenFrameworks. So I have to open class and added some feature in Ruby. And next, I will talk about how to convert the Ruby to GSL. But I use the DSL, and it will some limitation and some asymmetric problem. So the shader is I defined in C++, but I can use the open class feature. So the Vertex, I define a new method called Vertex. It will create my DSL generator and save the final code into the Vertex. The Vertex equal is also defined in C++ because I have to call some C++ API to make it link with the GPU. So I only define 5 to 6 methods in the C++, and I can do anything on Ruby. I did not write everything in C++. So if you write Ruby, you just learn the basic C++ skill, but you can still use your Ruby skill to write this. So if I want to convert the Ruby code should be a valid Ruby syntax. So I convert the Ruby code into the JSL code, but the Ruby code, it should be valid. But you can see my DSL, it's not like a Ruby. So I think you may think so, what happened? Yeah. The Ruby syntax, the DSL, I create. Okay. The deepest method will create some data object and return to next. And it will continue passing to, and the final method will capture it. And it will check it should export a code to JSL or do other things. So first, the type value defined. It will return the type object. You can see like this. I define a type, and it will save what is its type, and save the argument passing it. Because we did not to know the detail about GLSL, we just have to know the GLSL syntax. So how to define a new type? I just create a hash to save it, because we just save the type and the arguments into it, and everything will be work. But one more thing detail is about my type saver should save the type method in Ruby and the two type name in GLSL, because sometimes Ruby will convert the method name into lowercase, but GLSL will use the uppercase. So we have to save a type name to prevent it use the incorrect type. Okay, the next, when we return it and define a type, then I create a side node. How it work? It will receive the argument. So, and it will check is it an array. If it is an array, I think the other things is not needed, because I just want to receive one argument, and I will save it. This code is about my type define, so I will introduce this next. Okay, so when we call the is method, first it will save the type, and other things will be expression. Okay. And when we pass the value to the variable name, but we did not know what is the variable name user defined. So we have to use the method missing to capture it. So the method missing will check. First, if it is a side node, so I can guess it may be when to export into the GLSL code. So I do some export method. But if the method missing capture the name, the method name, and it is a constant syntax, so I guess it may be when to do some type define. So I will send a type define into it. So this is the reason why my is method to have to check is array. And if not a ball, and I can guess it may be just a variable. So when I finish this work, I can export a GLSL code. Yeah. But you may feel confused. Here I have a type defined, but why this did not have a type defined, but it still work? Because when I create the assigned node, I will check. Okay, it have a type. If it did not have a type, so I guess the user did not want to define a type, because he is already defined it. And the assigned node will provide a method called to. The to method will receive the variable name and check something. For example, it will check it has a type. If it did not have a type, it just return the name and the expression. So we can use image to figure out how it is work. First, I create a method code, and it may create some object. So if I define it is a type, so it's a type variable node. So it generates a type node, and it will check has type defined. Okay. If I defined a type, so it will edit a type node for it. And everything is finished. It will pass to the assigned node. So assign node will know if it is have a type or and the expression, and create a assign node for it. And finally, the variable method will receive this assign node. So it will think, oh, I got the assign node, so I have to export the code. And it will save to the buffer, and wait all code will be imported. So the GLSL variable usually like an object. So I can call something attributes. But how do we do it? We can use the method missing. I define a method missing and create a surface array. It will save everything I append to some variable object. So when I try to convert it to string, it will automatically append everything. So I did not know what is my variable type, but I just appended everything. So my GL DSL design is about how to convert the Ruby code into shader, but it is not about how to help you write a better shader. So when we done everything, we still have to some function, but the function code is very like variable. So I inherited it from variable object, and I modify some method to let it do like a function. So the function name and the argument will be added into it. And the final return string will be changed. We define the function like the type. We just create a label function array and define all function method. But the customer function is too complex, so I did not implement it. And you may think, why I not use the equal to assign a variable? Okay, you can see this code. When I use the DSL, the first line, this line, will be captured by class because the Ruby sync it is an instant variable, but the second line, this line, Ruby sync it is a local variable. So the method missing cannot capture it. So I have to edit the @ symbol before my variable name, but this is okay. Another problem will stop me to do this, because the GLSL is a typed language, so I have added the type for it. Now, we cannot override the equal statement function. So when I try to do this, the return value always be here, and not we expect the created object. So we did not know what is the variable we defined. And this line could be work, but it is not semantic. So we have to find something to change. So when I use the normal method code, I can overwrite the return value. So I always got the true. But when I use the assign, if I assign a 2 and I got 2, but I try to return 2, but I assign the false, and I just got false. So in this way, I have to change something. So the equal will be changed into the is method. So my code will be more semantic, and it also can use the I expect way to call the method. And we still have some problem about the arithmetic problem. When we try to call this, you may think it is also work. But every object is my custom type, so I have to create a calculable module for it and define all arithmetic symbol for it. But the toString already be used to create the variable or expression. So we have to define a new method called toExpression and join all the operation for it. But when we try to call the join method, Ruby default use the toString. So every calculable object will be not correct. So we have to expand the operation before the join method call it. So I fetch all operation and converted it to string, and the final it will join. So now I can use the arithmetic symbol in my code, but the call order will be incorrect because I'm missing the bracket. So next, I have to edit some brackets. This is simple because I just added a new node called brackets, and it will append the brackets for each arithmetic symbol. And we did not care about the call order because Ruby already know when the multiply or edit are call order. So finally, we get this code. And our GLSL generator is already done. So we can use this to generate the shader code. And now we still have some time to talk about how to embed it and Ruby in OpenFrameworks. Why I try to do this? Because if I write a C++ program, I make a small change, and I have to recompile it. It is slow, but if I just use the Ruby, I did not recompile it, and I can real-time change it. So in Ruby, if I want to define a class, I use the define class, and give it a current use the Ruby state and the class name and it inherited from object. If you did not know which object you want to inherit, just give the object class. And if we want to define method, just give the Ruby state the class which you want to define method for it, the method name and the method's body and which argument the method should accept. So the method body is a function point. It will return a Ruby value and receive a Ruby value. But if we want to create a two class for Ruby, we still have to save the data in the Ruby. So I create my example about how do I create a shader class for Ruby in OpenFrameworks. So first, I need to define a structure to save the data. I try to directly use the OF shader class for Ruby, but I have some problem. So I changed my code to like this. And Ruby have a data struct to save the class type. So I define the class type, and when Ruby's GC want to release this unused object, how to release it. So a free memory method will be placed in this. First, if we want to create a new data struct, we use the mruby's oracle method because mruby will add some header for it. And if we want to free the memory, we can just call the mruby free, but we still have the some point saved in our data struct. So we have to free this data struct before we free our defined struct for mruby. And the final, the method body, the initialize method, it's just like Ruby. So I define a class name called initialize. Then the Ruby create class, it also call it. So in our initialize method, we first check if there have any unexpected data in the class, and define the class type. Next, we oracle the shader and create our point and set it to it for this class. Now, you can write other required class for Ruby, and you can embed the C and Ruby in the OpenFrameworks. And I put my code on my GitHub, so you can find it on this URL. And the shadow generator, I think, is useful, so I separate it into another project. So I will demo how to real-time modify a Ruby code, and you can see I added a story into my example. Okay. First, I download a story model, but its rotation have something wrong. And my example code at here. The application code, so my source code is here. First, I added my model into it. Now I can load this model. So I added it. Okay. I changed the RubyKaigi's model, use the Tori model. Now I open the demo code. Okay. I did not save it. Oops. I opened wrong demo dictionary. Yeah, it's this. So I put the model into it. Okay, the tutorial is display. And if you want to change the shader effect, you also can do something about the shader. This is my diffuse shader I write in Ruby. So if you want to make it more light, I change the light color. So now you can see every model will be changed its light. The environment light will apply more power. So you can see the light will be very white. Okay. My talk is finished. Oh, thank you.